Hey Geometry, we've been using the Pythagorean theorem for quite a while. Today we're going to look at proving the Pythagorean theorem using similar triangles. Okay, if we look at this diagram here, let's see if we can answer some questions. So first I would like to write an expression in terms of C for x and y. Okay, where's x, y, and c? I have x and y and c. That's pretty simple. We're going to say x plus y equals c. Cool? All right, next question regarding this diagram is write a similarity statement for the three right triangles in the image. What we've done in the past is just looked at like short leg, long leg, hypotenuse, short leg, long leg, hypotenuse, short, long, hypotenuse, and put them in order. So let's start with the big triangle. We're going to do the short leg and then the long leg. So I did short leg, long leg, back to the hypotenuse. That is similar to, let's do the medium triangle next. Short leg, long leg, C, D, B, and then the little triangle. Short, long, hypotenuse. So short, long, hypotenuse, A, D, C. Okay, that works. Just warming up our brains right now. Now we're going to write down some ratios. And we're going to write down the ratios that I taught you during class this week. And just ratios to solve everything. So first I'm going to look at the hypotenuse and see if I can find a ratio that has to do with the hypotenuse. If we look at y over h equals h over x, that would be our ratio that has to do with hypotenuse. So y over h equals h over x, because those pieces of the triangles are similar, they're corresponding sides. Now I can look at the big triangles and the legs. I can say hypotenuse over A equals A over that short piece of the hypotenuse. And I can also say hypotenuse over B equals B over that piece of the hypotenuse. So I did C over A equals A over X. C over A equals A over X. I can also say C over B equals B over Y. Those are the ratios. Okay, now we're going to, our goal is to prove the Pythagorean theorem using what we know about similar triangles. So let's look at the right triangle shown here, where angle C is the right angle. And if you look, little c is across from that, little a is across, little b is across. We labeled them that way on purpose. So if you're following along, I would go ahead and label yours the same way. Next thing I'd like to do is draw the altitude, and I'm going to label it h. We draw the altitude h from the right angle to the hypotenuse, so it splits the hypotenuse at point D. Okay, giving us y here and x there. There's a better picture. It's the picture that we've been using up to this point. So we see that x plus y equals c. And I think that's all that we know, other than the three triangles are in fact similar. Okay, let's look at the ratios that we've written before. So we're working on proving the Pythagorean theorem using what we know about similar triangles and the ratios, the leg ratios. So let's first look at identifying the two triangles that have angle B as one of their angles. Okay, right there. I have ABC and CDB that are both those triangles. So since they're similar, let's look at the ratios that have to do with those two triangles. So the ratios we've used are C over A equals A over X. So big triangle, the big hypotenuse over hypotenuse equals hypotenuse over the long leg. So hypotenuse over hypotenuse, which is also the long leg of the big triangle. So big triangle hypotenuse over small triangle hypotenuse, which is also the big triangle leg, equals leg over leg. Okay, now we can look at the two triangles that have angle A in their measure. Angle A is a part of triangle ABC and triangle ADC. And let's write some equivalent ratios that have to do with that one. We can do C over B equals B over Y. I should also say that this gives us A squared equals XC, and this gives us B squared equals YC. We know that though. Okay, our goal is to show that A squared plus B squared equals C squared, and we'll get there. Okay. I need another slide though. Okay, I just copied that little piece over from the last slide. But let's see if we can do some substitutions. We know that we're trying to get to A squared plus B squared equals C squared. We know that A squared plus B squared is now equivalent to XC plus YC. Isn't that sort of cool? I can simplify that by factoring out this. Still pretty cool. We said in a previous slide that X plus Y equals C. Remember we had our triangle with the hypotenuse. We have X and Y, and the whole thing was C. So we said that X plus Y equals C. So I can substitute that. Ta-da! We just proved the Pythagorean theorem using similar triangles. Wasn't that fun? All right. Now let's do some problems. All right, the first exercise, find the length of the hypotenuse of a right triangle who have legs have lengths of 15, 100. You don't have to necessarily draw them out. Okay, it's pretty simple to know which ones if you have legs of 15, 100, you're trying to find the hypotenuse. That means you're trying to find C and you have A and B. And it doesn't matter which one you label A and B. It can be backwards or forwards. So 50 squared plus 100 squared equals C squared. That gives us 2,500 plus 10,000. Do some more addition. Here's where we're getting into the skills that we recently learned. Square root of 125, 12,500. I know it splits into 125 and 100. I know that 100 is a perfect square. 125 is 5 times 25. And 25 is a perfect square. So I'm sure I could have done this a little bit easier, but I just went with what I knew. So what comes out of the radical is going to be a 5 and a 10, and there is a 5 left over. So 50 square roots of 5 is what C equals. Can you think of a simpler method for finding the length of the hypotenuse in exercise 1? I mean, scale factors might work, but Pythagorean theorem for me is pretty simple. So it's really up to you. I don't have a good answer for that. It's up to you. I like the Pythagorean theorem. Yeah. All right, so let's look at, find the length of the hypotenuse of a right triangle whose legs have lengths of 75 and 225. I'm going to draw the triangle just so you can see it if you'd like to. Oops. If you could read it. Let's see if we can use a different method to solve this, just rather than doing the Pythagorean theorem. It might help someone. So if I have a right triangle whose lengths are 75 and 225, 225 divided by 75. Okay, this is going to be similar to a triangle that has leg lengths of 1 and 3. Okay, if I divide both of these by 75, I get 1 and 3. That's where that came from. So a right triangle with leg lengths of 75 and 225 have leg lengths that are 75 times longer than a triangle with leg lengths of 1 and 3. Okay, so if I have a triangle with leg lengths of 1 and 3, super easy to do that math, right? My hypotenuse is 1 squared plus 3 squared. So I have C as the square root of 10. Therefore, this is going to be, since here it's times 75, here it's times 75, therefore here it's going to be times 75. So my answer should be 75 square roots of 10, right? Let's check it really quick. 75 squared plus 225 squared equals C squared. 5625, 5625, add those two together, 5, 6, 250. So a square to both sides, square root of 56, 250. I'm going to go ahead and split that up into 10 times 5625. 5625 is the same as 75 squared, which we proved right there. So 75 square roots of 10. Same answer. Interesting. That was sort of fun. Okay, exploratory challenge. Let's look at this. An equilateral triangle has sides of length 2 and an angle measure of 60. As shown below, the altitude from one vertex to the opposite side divides the triangle into 2 right angles. And just so you know, that means that these are equal, those are equal, and those are equal. We have side, side, side. Oh, goodness. Right? That was a smiley face. Are these triangles congruent? Oh, yes, because I didn't even read the whole problem. Are these triangles congruent? I just proved to you that side, side, side shows that the triangles are congruent. I can also use side, angle, side. That will give me side, angle, side. And that would work. I could also use angle, side, angle, because we're told that these are equal, angle, side, angle, angle, side, angle, lots of different reasons. We also, when we have an altitude of an equilateral triangle, we know that these are equal too. It's a pretty fun triangle to work with. So Here we have 30 degrees. It's a 30, 60, 90 triangle. Let's go ahead and look at the next slide. What is the length of the shorter leg of each of the right triangles? I'm only going to do one because they're equal. So here we have 2, and that's all we know. If we know that before the altitude was there that it was an equilateral triangle, that means the whole side was 2. So we can actually say that each smaller triangle has a base of 1. So let's figure out what that other side is. I've got the shorter leg, sorry, and it's because it's an equilateral triangle, so each leg was 2 units long, so I'm going to split that base up equally, give me 1 and 1. So use the Pythagorean theorem to determine the length of the altitude. So here is 1, and that is 1. I'm going to have 1 squared plus b squared equals c equals 2 squared. B squared equals 3, b equals the square root of 3. So the altitude is the square root of 3. Write the ratio that represents the shorter leg to the hypotenuse. So I had a shorter leg, hypotenuse, longer leg. So the shorter leg to the hypotenuse would be 1 to 2. The longer leg to the hypotenuse is the square root of 3 to 2. And the shorter leg to the longer leg is 1 to the square root of 3. Cool. Push pause and write that down. Okay, by the angle criterion, any triangles with measures 30, 60, 90 will be similar to this triangle. If a 30, 60, 90 triangle has a hypotenuse length of 16, what are the lengths of the legs? So if we have 16 over here, we can use this 30, 60, 90 and the triangle that we just solved for, square root of 3, 1, and 2, to solve everything, right? So 16 is to 2 as the shorter leg is to 1. I just did 16 is to 2 as the shorter leg is to 1. So we can solve for that. Okay, cross multiply. We can make this 2s equals 16, s equals 8. I can do the same thing for the next one. 16 over 2 equals long leg over the square root of 3. So 16 square roots of 3 equals 2 times the long leg. The long leg equals 8 square roots of 3. Sort of fun. All right, next example, an isosceles right triangle has leg lengths of 1 shown. What's the measure of the angles? Well, this is an isosceles triangle, so I know the base angles are equal. I've already taken up 90 degrees, so these are both 45. What are the measures? Oh, check. Got it. Use the Pythagorean theorem to determine the length of the hypotenuse. I have 1 squared plus 1 squared equals c squared. 2 equals c squared. C equals the square root of 2. Is it necessary to write all 3 ratios? Shorter leg, hypotenuse, longer leg, hypotenuse, shorter leg, longer leg? No, because the legs are equal. Right, so we have shorter leg to longer leg is 1 to 1. And then hypotenuse to longer leg. Hold on, let me erase that. If we did shorter leg to hypotenuse and longer leg to hypotenuse, they're the same, right? It's 1 to the square root of 2, 1 to the square root of 2, because those legs are equal, so I don't need to write them all the same. Write the ratio that represents either leg to the hypotenuse. By the angle-angle criterion, any triangles that measure 45, 45, 90 will be similar to this triangle. If a 45, 45, 90 triangle has a hypotenuse length of 20, what are the lengths of its legs? So I can set up a ratio. Square root of 2 over 20 is the same as 1 over, let's just call it x. Okay, cross multiply. Square root of 2 times x equals 20. X equals the square root of 2 over, 20 over the square root of 2, which we will have to rationalize. 20 over the square root of 2, which I multiply by square root of 2 over the square root of 2. So 20 square roots of 2 over, this simplifies to square root of 4, which is 2. 10 square roots of 2. Very fun. That's actually the last slide, so we're done. The main thing today are 30, 60, 90-degree triangles. You have to have it memorized. The shorter angle, the small angle, large angle. Amazingly enough, I'll show you, let me finish writing. The way I always remember, the smallest angle has the smallest side, the largest angle has the largest side, and in between is square root of 3. 45, 45, 90. Okay, 1, 1, square root of 2. You have to memorize it. Okay, you'll need it. It's good. Good job.